Okay, this is the third video in the series on balancing solution oxidation reduction reactions, and this is the second video that deals with balancing these kinds of reactions by what's called the basic method. So the basic method actually is identical to the acidic method, the difference being once we have successfully balanced the equation using the acidic method, then there are two additional steps. The first step being the addition of hydroxide ion to cancel the H plus, and then the last step, which is to cancel any H2Os as appropriate to how they appear on both sides of the arrow. And what I want to do is, with this example, is do a problem that actually involves an equation that we split into two half reactions, and this one is pretty involved by comparison to the first example that I did. So let's get started. The first thing is being able to determine what the half reactions are, and usually you can see, when you look at the equation, you can see relationships. Like on the left side of the arrow here, there is aluminum metal, and then the aluminum appears in this ion here, and so it's likely that there's that these two, this element and how that element appears in this compound are related. And if we look at the oxidation numbers, the aluminum has an oxidation number of 0, and the aluminum that's in this anion actually has an oxidation number of +3. And the way we calculate that is by setting up an equation where we have aluminum. We're going to subtract that from the net charge on the oxygens. The oxygen's worth -2, and there's 2 of them, so it's Al -4. And then we set the whole thing equal to the charge on the ion, which is -1. When you solve for the aluminum, it's equal to +3. So in this case, the aluminum's going from an oxidation number of 0 to +3. So that means that the aluminum is actually being oxidized. So I'm going to write that half reaction over here, and we write it this way. So we have the Al going to AlO2 minus, and this is the oxidation step, so I'll just label it. And then by process of elimination, that leaves us with the other half, which is NO2 minus going to NH3. All right, and by elimination, this should be the reduction. Now we can actually prove that because the nitrogen that is in the NH3 is in the form of N minus 3. All right, and we can figure out the N in the NO2 minus by setting up an equation like we did for the aluminum. So it's going to be N minus 4 is equal to -1. So the N in this case is equal to +3. So you can see that the N in the NO2 minus is going from +3 to N minus 3 in the ammonia. So this is in fact the reduction step. Now, what we do next is we take both half reactions individually and we run them through the steps of the balancing. And when we get to step number 5, after we have completely balanced the individual equations, then we sum the two equations together, and then that brings us to the point where we have to add the hydroxide to both sides. So generally I like to start with the reduction reaction, although it doesn't make any difference. You can go either way, start with either one. It doesn't, the order is not all that important. So I'm going to start with the reduction, and the step 1 is to balance the non-O and non-H atoms. So that means we're looking at the nitrogens here, and they're fine. They're 1 to 1. So I'm going to rewrite my equation here. And the next step is to balance the oxygens using H2O. and we've got 2 oxygens on the left side, so we're going to need to put 2 H2Os here. All right, and the next step is to balance the hydrogens. Notice that on the right side of the equation that there are now a total of 7 hydrogens. I'm going to write that down. 7 hydrogens. So what we're going to do is add 7 H pluses to the left side of the equation. Okay, and what we do next is now balance the charge by adding electrons. So we need to sum up the charge on both sides of the arrow, and you can see right away that on the right side the net charge is 0. Over here on the left side though we have 7 hydrogen ions, so that's a total of plus 7, and then the NO2 minus ion, which is 1, so the total net charge on the left side of the arrow is plus 6. Alright, and we need to equalize that charge to 0. So what we're going to do is we're going to add a total of 6 electrons to the left side. I'll go ahead and do that. And then we write the rest of the equation. So at this juncture, this half reaction should be completed. And then I just want to, you should look very quickly and just double check to make sure that the charge is in fact equal on both sides of the arrow, which it is. We have 7 minus 1, which is plus 6, and then minus 6 for the electrons, which is 0. So this guy is good to go. So now we're going to switch gears and we're going to look at the oxidation step. Again, we balance the non-O and non-H atoms, and these are in good shape. The aluminums are the only concern here. So we can go to the next step, and in that one we want to balance O's using H2O, and since there are 2 oxygens on the right side of this equation, then we're going to add 2 H2Os to the left side. So it's going to be 2 H2O plus the aluminum to produce AlO2 minus. Alright, now the next thing is to deal with the hydrogens, and we see on the left side there are 4 hydrogens, so I'm going to write 4 H pluses over here on the right side of my equation. Alright, and at this point we're ready for the charge balance, and let's see, on the left side of the equation the net charge is 0. I'll write that down so it's clear. And over here on, or I meant on the left side, and over here on the right side the net charge is going to be plus 3. Alright, so now we need to make that charge go away, and the way we're going to do it is we're going to add 3 electrons. Alright, and let me just finish with the neutral side. Alright, now what we want to do next is inspect the 2 reactions, because we need to sum them back together. And what I mean by inspect is I want to look at my electrons, and you see for the balanced equation that came from the reduction side there are 6 electrons, and over here on the oxidation side we have 3 electrons. That's an issue. We need to equalize them up, because when we sum the 2 equations back together again, those electrons need to cancel out. So what we're going to do is we're going to multiply a coefficient through this equation, and the coefficient that I'm going to use is going to be 2, because we need to convert this 3 electrons into 6 of them. So let me go ahead and rewrite this. It's going to be 4 H2Os plus 2 aluminums to make 2 AlO2 minuses plus 8 H pluses plus 6 electrons. Okay, now we should be ready to sum our reaction, so I'm going to put my other arrow right underneath this one and go ahead and write the other equation underneath this so we can do canceling. So it'll be 6 electrons plus 7 H plus NO2 minus, and on the right side of the arrow we have the ammonia and 2 H2Os. Alright, we'll put a line under this. Now let's go ahead and do canceling. Alright, so the electrons cancel out, which is really good news. And let's see, what else do we have? We have H2Os on this side, and we have H2Os on this side. We're going to go to 2. Alright, so we're going to have 2 H2Os. I'm going to write that down here so I don't forget. We're going to have an NO2 minus. We're going to have the 2 AlO2 minuses on this side plus the ammonia. Alright, now we've got H pluses appearing on both sides of this arrow, so we need to do something about that. And I think what we're going to do is go ahead and cancel these guys right here, and that's going to leave us with 1 on the right side. Alright, and over here on the left side, let's see, make sure I have everything. Alright, we almost forgot an aluminum, so it's going to be the 2 Al. That should take care of everything. I'm going to go ahead and do canceling here just so I'm certain I have everything. Alright, so now we're in a position where we can now we can add the hydroxides, and so I'm going to rewrite my equation real quickly so we have more room. Alright, so we need to add enough H pluses to cancel, or excuse me, we need to add enough hydroxide OH minus to cancel the H plus. It needs to be added to both sides of the equation, just like in a regular math problem. You see right here we're going to end up with an H2O out of this. So this H2O is going to cancel with one of the H2Os over here, so I can rewrite my equation. And we should end up now with something which is properly balanced by the basic method. And just to be certain, we should have the charges should be the same on both sides of the arrow, which it is. Alright, so I'm just going to put a circle around this whole thing. So this is the correctly balanced equation by the basic method. And with that, I'm going to go ahead and close the video.